Sunday's Mars. These dark, narrow, 100-meter-long streaks called recurring slope lini flowing downhill on Mars are inferred to have been formed by contemporary flowing water. Recently, planetary scientists detected hydrated salts on these slopes at Hale Crater, corroborating their original hypothesis that the streaks are indeed formed by liquid water. The blue color seen upslope of the dark streaks are thought not to be related to their formation, but instead are from the presence of the mineral pyroxene. The image is produced by draping an orthorectified infrared red blue green IRB false color image ESP_030570_1440 on a digital terrain model DTM of the same site produced by High Resolution Imaging Science Experiment, University of Arizona. Vertical exaggeration is 1.5. Credits: NASA JPL, University of Arizona. Full image and caption. Editor's note: the findings described in this press release were updated with additional research published on November 20, 2017, and described in Recurring Martian Streaks, Sand, Not Water. New findings from NASA's Mars Reconnaissance Orbiter (MRO) provide the strongest evidence yet that liquid water flows intermittently on present-day Mars. Using an imaging spectrometer on MRO, researchers detected signatures of hydrated minerals on slopes where mysterious streaks are seen on the red planet. These darkish streaks appear to ebb and flow over time. They darken and appear to flow down steep slopes during warm seasons, and then fade in cooler seasons. They appear in several locations on Mars when temperatures are above -10 degrees Fahrenheit, -23 Celsius, and disappear at colder times. Our quest on Mars has been to follow the water in our search for life in the universe, and now we have convincing science that validates what we've long suspected, said John Grunsfeld, astronaut and associate administrator of NASA's Science Mission Directorate in Washington. This is a significant development, as it appears to confirm that water, albeit briny, is flowing today on the surface of Mars. These downhill flows, known as recurring slope lini (RSL), often have been described as possibly related to liquid water. The new findings of hydrated salts on the slopes point to what that relationship may be to these dark features. The hydrated salts would lower the freezing point of a liquid brine, just as salt on roads here on Earth causes ice and snow to melt more rapidly. Scientists say it's likely a shallow subsurface flow, with enough water wicking to the surface to explain the darkening. Dark narrow streaks called recurring slope lini emanating out of the walls of Garni crater on Mars. The dark streaks here are up to a few hundred meters in length. They are hypothesized to be formed by flow of briny liquid water on Mars. The image is produced by draping an orthorectified red image ESP_031059_1685 on a digital terrain model DTM of the same site produced by High Resolution Imaging Science Experiment, University of Arizona. Vertical exaggeration is 1.5. Credits: NASA JPL, University of Arizona. Full image and caption. We found the hydrated salts only when the seasonal features were widest, which suggests that either the dark streaks themselves or a process that forms them is the source of the hydration. In either case, the detection of hydrated salts on these slopes means that water plays a vital role in the formation of these streaks, said Luhendra Ojha of the Georgia Institute of Technology, Georgia Tech, in Atlanta, lead author of a report on these findings published September 28 by Nature Geoscience. Ojha first noticed these puzzling features as a University of Arizona undergraduate student in 2010, using images from the MRO's High Resolution Imaging Science Experiment HiRISE. HiRISE observations now have documented RSL at dozens of sites on Mars. The new study pairs HiRISE observations with mineral mapping by MRO's Compact Reconnaissance Imaging Spectrometer for Mars PRISM. The spectrometer observations show signatures of hydrated salts at multiple RSL locations, but only when the dark features were relatively wide. When the researchers looked at the same locations and RSL weren't as extensive, they detected no hydrated salt. Ojha and his co-authors interpret the spectral signatures as caused by hydrated minerals called perchlorates. The hydrated salts most consistent with the chemical signatures are likely a mixture of magnesium perchlorate, magnesium chlorate, and sodium perchlorate. Some perchlorates have been shown to keep liquids from freezing even when conditions are as cold as -94 degrees Fahrenheit, -70 Celsius. On Earth, naturally produced perchlorates are concentrated in deserts, and some types of perchlorates can be used as rocket propellant. Perchlorates have previously been seen on Mars. NASA's Phoenix lander and Curiosity rover both found them in the planet's soil, and some scientists believe that the Viking missions in the 1970s measured signatures of these salts. However, this study of RSL detected perchlorates, now in hydrated form, in different areas than those explored by the landers. This also is the first time perchlorates have been identified from orbit. MRO has been examining Mars since 2006 with its 6 science instruments. The ability of MRO to observe for multiple Mars years with a payload able to see the fine detail of these features has enabled findings such as these, first identifying the puzzling seasonal streaks and now making a big step towards explaining what they are, said Rich Zurich, MRO project scientist at NASA's Jet Propulsion Laboratory JPL in Pasadena, California. For Ojha, the new findings are more proof that the mysterious lines he first saw darkening Martian slopes 5 years ago are, indeed, present-day water. When most people talk about water on Mars, they're usually talking about ancient water or frozen water, he said. Now we know there's more to the story. This is the first spectral detection that unambiguously supports our liquid water formation hypotheses for RSL. The discovery is the latest of many breakthroughs by NASA's Mars missions. It took multiple spacecraft over several years to solve this mystery, and now we know there is liquid water on the surface of this cold, desert planet, said Michael Meyer, lead scientist for NASA's Mars exploration program at the agency's headquarters in Washington. It seems that the more we study Mars, the more we learn how life could be supported and where there are resources to support life in the future. This animation simulates a fly-around look at one of the places on Mars where dark streaks advance down slopes during warm seasons, possibly involving liquid water. This site is within Hale Crater. The streaks are roughly the length of a football field. There are 8 co-authors of the Nature Geoscience paper, including Mary Beth Wilhelm at NASA's Ames Research Center in Moffett Field, California and Georgia Tech, PRISM Principal Investigator Scott Murchie of the Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland, and HiRISE Principal Investigator Alfred McEwen of the University of Arizona Lunar and Planetary Laboratory in Tucson, Arizona. Others are at Georgia Tech, the Southwest Research Institute in Boulder, Colorado, and Laboratoire de Planetologie at Géodynamique in Nantes, France. The agency's Jet Propulsion Laboratory JPL in Pasadena, California manages the Mars Reconnaissance Orbiter project for NASA's Science Mission Directorate, Washington. Lockheed Martin built the orbiter and collaborates with JPL to operate it. More information about NASA's journey to Mars is available online at. For more information about the Mars Reconnaissance Orbiter, visit N. Wayne Brown Glory Cantillo. Headquarters, Washington. 202-358-1726 202-358-10